What's up, everyone? Welcome back to Java with Hawa. Today we're solving elite code problem called threesome. And as you know, I am on the two pointer pattern. That's what I'm trying to learn. And I'm super rusty, so definitely don't judge. But this video is just going to be the theory of this problem and how we're going to approach it. And then we'll move on to actually coding it. So the problem says, given an integer array nums, return all the triplets nums at I, nums at j, nums at k, such that I does not equal j, I does not equal k, and j does not equal k, and nums at I plus nums at j plus nums at k equals 0. Notice that the solution set must not contain duplicate triplets. Okay, so let's just start with how we're going to approach this problem. So I'm going to make this bigger. And so let's see the first example they give us. So they give us the example of -1, 0, 1, 2, -1, -4. And with the knowledge that something like the two-pointer pattern might help us here, we can think of how we can maybe sort these numbers in such a way that we can keep track of bounds. So we can know something like, hey, if these three numbers are smaller than 0, I know maybe I need to go to a bigger number over here. Or similarly, the opposite case, you can say something like if these were sorted in some fashion, you could say something like, are these three numbers greater than 0? If so, then maybe I need to try to move a little lower so that I can get closer and closer to my target value of 0. And that's the whole idea of sorting. So let's see how that looks. So if we were to sort these values, we'd have -4, -1, -1, 0, and 2. Okay, and the way we're going to approach this problem is we're going to have an outer loop that goes through each of our entries. And within each step or each iteration of our outer loop, we're going to have an inner loop that utilizes the two pointer approach to try to keep track of two numbers. So let's try to solve a simple case of just trying to see if two numbers, I and j, equal to some target value. Okay, so suppose to do this, we have a regular two pointer approach, and we say something like, hey, I have one pointer starting here and another pointer starting at the end. And you're just going to ask yourself. So in this case, let's do the example of maybe target equals -5. Okay. So in this first iteration, you'd say, hey, is -4 plus -2, is it equal to, so you have three cases. The first is it equal to your target? Is it equal to -5? In this case, it's not equal because this is -6. So we move on to the other case, which is, and if it was equal, you'd just like return true or something, indicating that this is a valid pair. And if it's less than, you'd say is -4 plus -2 less than the target value of -5. In this case, it is. So you know at this point that your lower pointer over here, it must be too low because you're getting a value that's less than your target value. So ideally, you would move that pointer up by 1 because, and that indicates that you're trying to somehow get closer to your target. And because this is a sorted array, you know that these arrays are in ascending order, meaning that the values are only going to get bigger. In this case, I don't even think we'd find a solution in this way, even though there is a solution, which is -4 and -1. Yeah, I mean, I guess we would find a solution if we get to -1. Actually, I don't know. Anyway, this is just this is just an example. So that's kind of how we're gonna approach this problem. But now, oh, oops. Okay, but now we're introducing the idea of three values, not just two values, not just these two, but let me take this out. But we're introducing the idea of having three values. So, as I said, we'll have an outer for loop that will traverse through each of these, right? And within each of those, we have our inner for loop that has two pointers that will go through the array and see if the outer value, so let's call the outer value current, which will be the iteration, the outer iteration. So in this case, it would be like nums at I if we use the variable I to iterate. So if we say current equals nums at I, then we'd say, hey, int sum. So right now my current sum equals current plus nums at this lower pointer plus nums at this higher pointer. So you have access to three values at the same time. And that's what makes this two-pointer approach so valuable, because you can have access to potentially 2 to 3 values or even more if you'd like. And in this case, after we calculate the sum, we ask the three cases. Is it equal to 0? Is it greater than 0? Is it less than 0? And we just saw that if it's less than 0, we just need to increment our lower pointer up by 1 to try to increase our value to get closer to the target of 0. If it's less than 0, we know that we need to decrease our higher pointer. So this pointer here, we need to move it down, because since it's sorted, remember that's the key. If it's less than 0, wait, this less than 0? Sorry, I mixed these up. So this is the symbol for if it's greater than 0. We would move the higher pointer downwards, indicating we want to decrease this values until we get closer to 0. And again, if it's less than 0, like I mentioned, we would move the lower pointer upwards. Now, this problem has a couple of cases we also need to take care of for if our value equals 0. So let's look at the example they gave us, -1. Sorry, if it's, let's imagine that we sorted that. So -4, -1, -1, 0, I think it's 1 and 2. Yeah, 0, 1, and 2. So this is the sorted value. So suppose we use our approach. We know in the instructions, they say that the solution set must not contain duplicate triplets, okay? So that means that if -1, -1, 2 is one solution, we only want this to appear one time. So that's the first thing that we have to take care of. And obviously, the second is making sure that all values appearing in here are different elements in an array, meaning they lie at different indices. So that's why you can use -1 twice here. Okay, so how are we going to take care of the case where we don't want -1, -1, 2 to be printed 2 times or to be added to our resultant array list or list more than once? So what we're going to do is, like in our iteration as we're going, right? Let's say we get over here and we see, I don't know if this example would produce that. I'm going to add one more value of -1 here, okay? So let's say in our outer iteration, this is where the current number is, right? We get to -1. So we have our inner loop. And also I didn't mention that the low pointer should start at 1 plus the ith value, because we want distinct elements. The ijk need to be distinct. And our higher pointer will start at the very last position in our array. And one thing to note is how long are we iterating for in the outer loop? Well, we're not going to go all the way here, because suppose we do go all the way, iterate all the way to the end of the array. In that case, we try to, this is I, we try to set low at I plus 1, which is here. And that's out of bounds since there's no element. And then we'd also set the higher pointer over here. And that's the same as the ith pointer. And that would result in a duplicate element. So really, what we have to do to take care of this case is make sure that we iterate up until the length of nums minus 2. So over here, I should stop iterating after it executes nums.length minus 2, because in this case, we know for sure that low equals to I plus 1. It will be at a valid index. And also our ending element is here, the high pointer. And all these three elements would be distinct such that we fulfill the case that I does not equal j, I does not equal k, and j does not equal k. Hopefully that makes sense. So back to that example I was talking about. of the duplicate values. So let's say that our ith value is here at the current value, and we have -1. And we end up finding that using our low and high pointer approach, we find out that -1, -1, and 2 add up to 0. So now you might think that's it, right? We just have to add it to the array list and we're good to go. But there is a potential for duplicate elements. And because it's sorted, we can use the sorting to our advantage. So if we keep going, like let's say we finish that, we add these 3 values, and then we say, okay, let me move my low pointer up now and my high pointer down. So if you move your low pointer up and you're at -1 again, this means that you're going to get the same exact result as this, right? Because here you had -1 on the low pointer. So if you have -1, so if you have current equals -1, and then you have low equals -1, the only other possible solution for this is going to be 2, because if you do -1 plus -1, let's say -1 plus -1 plus x equals 0, the only other solution in this case is going to be 2. So that means x has to be 2. So you're going to get a duplicate value. And the way we're going to take care of this is whenever we find a sum equal to 0 and we add those nums into our array list, like let's say when we're here, when low pointer is here and high is here, and we add -1, -1, and 2 in our array list, we're going to make sure to increment low until it's not the same number as we've already have. So if you say low plus plus here, right, and you see another -1, well, you're going to get the same exact triplet. So you're going to say, hey, keep moving -1 until it's at a different value than what I've already used to compute my triplet. And similarly, you're going to do the same thing with high. So if there was another 2 over here, and you get the triplet -1, -1, 2, so you have current equals -1 and high equals 2, right? -1 plus 2 plus x equals 0. Well, you know that the only other possible value for x is going to be -1. So in this case, you'd have a duplicate triplet if you come upon another 2 as your high pointer. This is getting so messy, but honestly, I haven't slept all night and I'm really tired. Maybe I'll redo this video, but hopefully it's easy to follow. I'm not even following this. Okay, I am following it. Okay, so high, if you move high over here to 2, well, you're going to get 2, -1, -1 again, and that's duplicate to here. So you need to move your high pointer minus minus, keep moving your high pointer downwards this way until it's not the same as something that you already used in your current computation with the current ith value. And hopefully that makes sense. And with that same, wow, this is a mess. Oh my God. With this same case in mind, I don't know if I can, let me just write it again. With this same case in mind, -1, -1, 0, 1, 2, you also want to check your outer for loop, right? So in your outer for loop, because in each iteration of the outer for loop, you're going through the entire list in your 2-pointer fashion, okay? So this is the inner loop, and this is the outer loop. So each iteration of this, you're doing this entire thing. So one other thing you want to check in your outer loop, if we're using the variable I to iterate through this, you need to make sure that, let's say I is -1, right? And you compute some triplet like -1, -1, 2. And then the next iteration, you say I plus plus, so here's I again. But I again is -1. And since in the inner loop of the previous iteration, you already went through all the values, you're gonna get duplicate triplets if I is the same again, because you're again gonna go through the values. You have a potential to get duplicate triplets within the bounds of your low pointer and your high pointer. And the way we're gonna mitigate this is the same way as the case where you're already in the inner loop, which is, hey, if I is not at the first element, then make sure to check if nums at I is equivalent to nums at I minus 1. Meaning, hey, if I've already seen this number as my current, then I've already generated all the valid triplets for it, and I don't need to check this again. So you can just continue. And yeah, that would check for this case and ensure that you don't have any duplicate triplets. So that's all for this theory part. Hopefully that makes sense. And yeah, let's move on to the coding part. All right, so getting right into the code, right? Recall that we have this integer array nums. We want to return all triplets nums.I plus nums.j plus nums.k such that they equal to 0 and such that all I, j, k are distinct elements. And also with the extra caveat that all triplets that we add in our output are also distinct. So we don't want two of -1, -1, 2 because it's the same thing. So, just following from the theory in my iPad, my messy explanation that I did because I haven't slept in 10 hours. And, anyways, I think it makes sense. So, first, I'm just going to do a check. If nums, I'm trying to be a robust programmer. So, if nums equals null or nums.length is less than 3, that tells us there's no way we can even have a triplet, first of all, with this case, and this is null. So we're just going to return a new array list, empty array list, new array list. And let's construct that, initialize that. Okay, cool. Now that we've elevated our status as programmers by doing these extra checks, we're going to sort this array so that it can help us in the computation of seeing whether our sum is too low or too high and how we can move our pointers inward. And also will help us to determine if we've already used the same value to compute a triplet. That way we won't have duplicate triplets in our result. So arrays.sort nums. Okay. And also before that, I'm actually going to create the resultant output. So I'm going to say list integer, and we'll call it results. Oh, I'll call it triplets actually to be more descriptive. And we'll initialize that as an array list of integers. Okay, cool. And we sort the array list, and now we can start with our outer for loop because remember we need to keep track of 3 values. So our outer for loop will keep track of 1 value at a time, while our inner for loop, for each step in the outer for loop, our inner for loop has 2 pointers. One is low, which starts at I plus 1, so low would start at 0 in this case, and the other starts at the end of the array. And these will inch towards each other based on if the value is greater than 0 or less than 0 or equal to 0, and perform extra checks. So we'll get there in a sec. So we'll say for in I equals 0, I is less than nums.length minus 2 I plus plus. And recall that we are looping until I is, actually this should be less than or equal, right? Because nums.length, this is nums.length minus 1. No, it should be less than. Okay, so while I is, and the reason we are going to I is less than nums.length minus 2 is because we know that at each iteration of the outer loop, let's say the outer loop I is at 2, we know that the inner loop, right, the 2 pointers, the low has to start at I plus 1, which is going to be here. And the high always starts at the end. But let's say we decided to iterate until I is less than nums.length, right? And through the entire array for our outer loop. Then when I is at -4 here at the last element, in our inner loop, we'll have low equal to I plus 1, which will be over here, and it will be out of bounds, causing an array out of bounds exception. And the likewise, or similarly, the high pointer would be at the same thing that I is pointing to. And that would lead us to not having distinct elements, meaning this property here would be violated. This I does not equal j, I does not equal k, and j does not equal k. And that's why we go until I is less than nums.length minus 2. Okay, so actually with their example, I want to try to write out the steps. So here, when we sort the array, we'll have -4, -1, -1, 0, 1, and 2. Okay, and now let's go through these. So we're going to say int Okay, what are we trying to say actually? So the first check we want to do, right? So let's say I is here, right? And within our inner loop, maybe we found a valid triplet that is like -1, -1, 2. And we move on to the next iteration of our outer loop. So we were here, and I plus plus brings us here. So if we use -1 again, we know we're going to get a duplicate triplet possibly because in this loop, right, in this iteration, in the inner loop, we've already gone through all the possibilities that are after it, right? So if we again have -1 and we go through more possibilities that are after this one, well, that's going to either create a duplicate or mess things up. So if we come upon the same number that we've already just checked, then we're just going to continue and we're going to skip over it because we're going to say we don't want any duplicates in our resultant triplets array list. So let's check if, what are we checking here? So we're going to check if I is greater than 0 and so we're going to check if I is greater than 0 and num.I, the current element we're on here, if that equals the previous I, equals num.I minus 1, then we're just going to want to continue because we don't want those duplicates. Okay, cool. And now once we've done that, we can get into the actual bulk of the logic. So we're going to say int low equals I plus 1. So now we're setting up that inner 2-pointer maneuver. And so if this is I, right? So let's illustrate this really quick. If this is I, then here is going to be low, which starts at the value after I, because remember that I should not equal j and should not equal k, and all these three elements in our triplet should be distinct. So we start low here, and we start high all the way out here, and we start inking these together and checking, hey, are the three values I'm on equal to the sum? If they're not, or if they're less. If it's less than, move low over here. If it's too high, then let's move high downwards, so on and so forth. So this is the inner loop, and this is the outer loop. So let's do this. So int low equals I plus 1, and int high equals nums.length minus 1. So starting at the last element. So we're going to say, while low is less than high, meaning while these 2 pointers have not overlapped, right? Because if they overlap and high is here, we'll know that we already checked all the possibilities that were in the bounds. So we don't want that to happen. So we're going to say, while low is less than high, while low is less than low. Okay, while low is less than high, first let's calculate the sum of the current three numbers that we are on. So -4 plus -1 plus 1 in this case. So in sum equals nums at I plus nums at low plus nums at high. Okay, and we'll just check here if sum is 0, if we've hit our target, then we're gonna create a new array list. We're gonna say list integer result equals new array list. We'll initialize that as an array list. And let's just pass arrays dot as list, and we'll just pass in these three num values. And remember, we're not passing in the index, we're passing in the actual value. Because I know a lot of questions ask us to pass in the index of where they're located, but this one is a bit different. Nums at I, nums at low, and lastly, nums at high. Okay, oops. Okay, cool. So now once we create that array list, let's just insert that into our triplets resultant list. So triplets.add result. Cool. And now we have to do those extra checks that I mentioned, meaning, okay, once we're in the inner loop, right? And let's say there's another -1 here, and low, let's say I is over here, okay, and low was here, and high was at 2. So now you found these three values that add up to 0, and you're like, cool, let me keep going within my inner loop. So you decide to move low up here, and you keep high at the same spot. Well, you're still going to get the same result, -1, -1, 2, because you already checked -1 against your current value. So the only other possible result is 2 in this case. So what we need to do is we need to move this low pointer until it's not the same value as it was before, until it's not -1 again, until it gets here. Then we're like, okay, we're good to go. We can use this now because it's a new value that we haven't seen yet. And likewise, we'll do the same with the high pointer. So as I mentioned, if we have 2 here, okay, and we already found the current iteration, this is the current element and this is the inner loop. We found these 3 values, right? And if we do high minus minus, well, we're at 2 again. If we compare 2 with the current value, the only other possible value is -1, and we're going to get a duplicate triplet, which is why we need to make sure to keep moving this high pointer down until we don't have the same value that we already used in our current iteration. So let's take care of that. So we want to increment low plus plus because we've just successfully added that. And we want to say while low is less than high, while it hasn't overlapped yet, we still have elements to check that could possibly be low. And if the current low we're at is equivalent to the low that was before it, if it's both, so here we're asking, this is the low I'm at. If it's the same as the low before, just keep moving this thing because we don't want that. So while low is less than high and add nums at low is equivalent to the low before it, nums at low minus 1, then we just want to keep moving low forward. And likewise, we're going to decrement our end pointer, right? Because we found this result. We found 2, and we want to move this downwards to maybe another potential result. So high minus minus. But again, we're going to say, hey, I don't want the same high that I've already used because that's going to give me a duplicate triplet. So we say, well, high is greater than low, meaning well, high does not surpass low. And nums at high, so if we do high minus minus, will be here. And we say, hey, well, this is greater than low, meaning it hasn't passed low. And also, while this nums at high is not, if it's equal to the nums right after it, meaning nums at high plus 1, then you want to keep moving this downward until it gets to a unique element. So a high is less than none, nums.high equals nums at high plus 1, high minus minus. Okay, cool. And once that's done, that should be it for here. Now we just take care of our easy cases, which is what if my sum was less than 0? Else if sum is less than 0, in this case, we know we just want to move the low forward by 1. And if it's greater than 0, we just want to move the high pointer down by 1. And now, after this loop ends, after this for loop ends, we can return our triplets result. Cannot find symbol. Okay, so this should be nums. Okay, cool. Submit. Okay, awesome. So looks like that worked. Oh, I accidentally paused it. So yeah, it looks like it worked. Let me know if you have questions. Sorry for that horrible iPad demo. The messy demo. I am going to sleep now. As you can see, oh, maybe you can't see the time, but it's 7 a.m. I'm gonna take a nap before school. Okay, bye. See you guys in the next video.